Well, hello, and thank you, Kim, again for being part of Mem Tips and Tricks. This is part 3. So,
Part 3 and probably the final part.
yes, the final part. I guess we've been through a lot of stuff in part 1 and part 2. In part 1, where we looked at what is WDAC, we looked at what can it help with, and does it bring a lot of overhead? And in the part 2, where we looked at how do we set it up and where should we set it up in Intune, config manager, group policies, local policies. We also looked at why do the Intune WDAC policy reboot our devices when enabling the policy, even in audit mode. We looked at the need of centralized events gathered from the devices and how much that costs.
Yeah.
And we also looked at how we can use advanced hunting in Defender for Endpoints. So I guess we've been through a lot of stuff, Kim, already. And I get the feedback from users that you're really good explainer. So the stuff you go through when you explain about WDAC, it's good information, and from what I read from the users, they understand the content you provide. So
That's good to hear because we've been doing this for a quite large number of months, if not 2 to 3 years, and then you tend to start thinking all of this is pretty self-explanatory because you've done it this many times. But for many, it is not. Tom is typically my guardian on making sure I keep things simple enough. So that's good to hear.
mhm, yeah, I think so too. And people have had time to ask questions on part 1 and part 2. So the part 1 came out the 14th of February, and the second part came out yesterday, actually this morning, 1st of March.
I saw the tweet.
The first day that is not winter. It's a great day to publish a video, I think. So that's that said. Of course, our part 1 got lots of views already. Actually, it's one of the most viewed videos on the channel. It got 1,161 views. That's a really good job, and 16 comments. Wow.
Well, we're hoping more and more people start investing time in WDAC. So the more people that watch it and get interested, the better, because it's for technology that you're already licensed for, it's extremely powerful.
Exactly. Exactly. And that's why not use the Microsoft Stack once you have the license, right?
It makes quite a lot of sense to at least investigate whether you can do that or not.
And then on the second part, of course, it was published this morning. So 214 shows has already been going on, and 3 comments. And we actually have a 3 questions coming from one of the YouTube viewers to this show, and we'll take them in the last bit of the video. But this part 3, Kim, we're going to look at some real life examples. We're going to look at okay, if I am a user in a company where we have WDAC enabled, and now you suddenly start blocking apps that has not been whitelisted, and as a user, mm, I want to see some information what happens. So how can your company provide good information to the user?
Well, we explained our setup in the first video. What we didn't do is actually show what it looked like for the user. So I'll share my screen. That should be better. All right, so I've opened up Windows Explorer in the downloads folder. I've downloaded Chrome setup.exe, and as a user, I intend to start installing Chrome, which my organization has not sanctioned me to do. So if I run Chrome setup.exe, what you get is this typical blue screen or blue window. It's not a blue screen, but it's the blue window that is native to Windows Defender Application Control. Okay, which says we block this, contact your support person. This is the file we blocked. And you can copy this message to clipboard or close it. But this is a fairly rudimentary message. All right, so with our setup to look at messages like this, we created something that keys off of an event viewer event. But once that happens, we actually trigger the toast notification based on the script that Martin has created that basically says an application was stopped from running. And it gives you some explanation as to why we do this. Right? So for security and stability reasons, blah, blah, blah. We don't want you to run software that we haven't determined as being okay to run in our environment to avoid you running malware or ransomware. And the text goes on, if you believe this application should be allowed, then please register a ticket with a button that basically takes you to your ticketing backend servers. There's a learn more that in this particular case just sends you to our WDAC training page, but you could have a page up on the internet that explains what is going on, and you can dismiss it. That's roughly what we do. This event can actually trigger an end user registering a ticket, but in the back end, we've been using a webhook into Teams to automatically generate a message for us, so that even if the user does not register a ticket, we actually see something was actively being blocked and stopped.
That's quite smart.
Yes, because the discrepancy between this popping up and the user effectively being blocked from running an application, that user not registering a ticket is typically interesting to us as well. Because if you're trying to run something and it's not allowed to run, why wouldn't you register a ticket? So then we want to know what was going on there. So that's why we typically log those as well.
It could be that the user was trying to install Steam and they were embarrassed by that.
We don't have actual statistics, but what we do see is that the people that do not register a ticket, on a higher percentage at least, we're trying to execute or install something that they probably knew that they shouldn't be doing. Whereas for the ones that do register a ticket, obviously that number is a lot lower. And it is somewhat surprising, though, in our meetings with customers, how many people still register a ticket and a complaint to install something to which they probably should know that they're not supposed to do that. So that's interesting. So those tickets obviously get just closed and the user gets a message. Our policy does not allow you to install pieces of software this way. We have alternative procedures for that, where you can request a software intake and things like that. Is typically what the response is. But that's typically the end user UI that we go with. Because one of the things that you cannot avoid is that software that is supposed to be running is still blocked for one reason or another. That's a case that you'll just have to take into account, that you need to have a procedure to actually be able to handle that. So that's why we have this bit.
That's pretty cool, because that blue box in the middle didn't really give me much as a user.
No.
I could copy it to the clipboard, but again, where should I put that data? I mean,
yeah, the blue box typically generates help desk calls. I have this. What's going on? So you get a bunch of requests randomly going to the help desk. At which point in time, help desk needs to ask, okay, so what file was this that's being blocked, and so on. Whereas with our pop-up or those notifications that we generate ourselves, there's much more sensible information that we can give, and depending on your service ticketing mechanism, we can actually already enter quite a bit of information in the ticket, provided that the web service that drives your ticketing system allows us to do that. That would allow us to register what computer it came from, who the user was that is logged in, what file was actually being blocked, and things like that, so that the user does not have to enter all that information by themselves.
That's a good idea.
Yeah, that requires some tweaking and some knowledge of your web service, but shouldn't be too much of a challenge to handle.
No. So I noticed you said that you had a webhook into Teams. So I guess the thing is, when you dismiss this and it puts the information into a team where the IT operations sit and look at these, or maybe don't, but they have the possibility to look at it. What happens if we have an environment where you have like 50,000 devices and maybe 10% of the devices see these pop-ups and click dismiss? Wouldn't it be an explosion of information in that Teams channel?
No, it won't be an explosion in the Teams channel, but it will provide a problem. The Teams webhook actually works with quota. So at a certain point in time, our webhook will start failing because Teams says, I've had enough. You seem to be spamming me. The hell with that. No longer sending on the messages. Right? So in that large of an environment, that would provide a problem, or that could provide a problem. That being said, we only move to enforced mode, which is when this kicks in, if we're pretty certain that a user will not see a whole lot of messages on a regular occurrence. Right? So even if you do this and you manage to get an environment of 50,000 devices, all 50,000 into enforced mode, that would only happen if we've managed to get the number of events that is reported way down. So even in those environments, it could potentially still work, but we might end up with a new executable that is added to the environment for whatever reason that we have forgotten to make trusted. And at that point in time, we would actually break the webhook because the quota would kick in immediately, and we'd have to wait out for the quota to clear.
That's good to know.
So for environments of that size, you probably want to look into an alternate mechanism than a Teams webhook to surface this. Right? But all of this is just the toast notification script of Martin that's quite flexible in what some of the buttons do. So if you want another mechanism to handle this, you definitely could.
That's cool. And the toast notification is Martin Bengtsson, the MVP, right, from
Yeah.
Denmark. Yeah.
Yeah.
Yeah. Just to quote him when we are done with this video. So thank you, Martin, for creating this cool template of toast notification for many things we can do.
Yep.
So that's very cool. Okay, so what I thought when I went into this WDAC talk is that it must be a pain to operate this in real life. And Kim, I know you have experience from a lot of environments where you have actually operated this. So when we've had the audit mode and we've said, okay, there's no events coming in, or at least it is not getting our webhook to fail, and we enforce this policy. Now we are in operation, and operation is constantly moving, right? So we need to get new applications, upgrades of applications, and all that. How do we operate it in the real life?
Well, there's a couple of things. One, obviously, there is an operating cost to this. There is overhead in doing this. We typically say is that overhead largely should be shifting some of the security work you do in trying to mitigate a bunch of vulnerabilities by doing this, right? And at least buying you time to implement other mitigations should they be needed. Right? So that's one part of the equation. The second part of the equation is that you cannot overestimate how difficult this needs to be. I'll probably start sharing another screen because that's where I have the other stuff going on. So that's this screen. You shouldn't overestimate the amount of effort you actually have to put in to make things trusted. Most applications are fairly easy to make trusted with the catalog mechanism we talked about in the previous video. And the catalog mechanism is basically just one executable. It's called package inspector. Didn't I have that open? I did, but apparently on a different page. Okay, so here it is. No. I've closed it again. I'll reopen it and move it here. There's basically one executable that's called package inspector.exec. And it, in essence, has two different ways of generating the catalogs. Right? One is the start-stop mechanism. Right? So that's this. Right? Basically tell package inspector, start monitoring a particular drive, right? Or a particular path if you really want to do this. Right? And then package inspector stop, you tell them, okay, now stop monitoring and tell me everything that has changed on this particular drive during the installation. Right? That's roughly what package inspector start and stop do. And they make use of a feature in an NTFS called NTFS journaling. And NTFS is just journaling, as the name implies. It's basically a journal that's kept on changes that are made to an NTFS file system. And it looks at all those files, all the files that have been created or changed during the start and the stop are added to a catalog file. You sign the catalog file, you distribute the catalog file, and you're done. That's it. We often get the question on, okay, so there's this piece of software. it's a nightmare piece of software. There's no way I can package it for distribution with SCCM or Intune. This just requires a serious amount or a number of manual steps that we need to run through. There's no way we can package it. So there's no way we can automate the catalog for it. That's fine. And we'll just manually create the catalog. I'll do package inspector start. You do whatever actions you feel you need to take to install this piece of software. You do package inspector stop, and the catalog is created. So this is a process that is recurring and is the same for any piece of software you want to install. There's no exceptions here. There's no things where, okay, is the silent install switch -s/q/quiet/whatever. How do I package this thing? If you can't package it, okay, then we'll manually create the catalog. That's fine. How the catalog gets generated doesn't matter. So that's one way of creating the catalog. And since it's a very simple process, it's easy to write 10 lines of instructions for anybody that needs to be able to install software on how to create that catalog. That's it.
So one question to that. So if the package inspector will record everything that happens on a particular drive, wouldn't it be a good idea to have a virtual machine doing this?
Yeah, that's we talked about our automated engine that does this. So we have the automated engine. The automated engine for us is a virtual machine, and the virtual machine does not have internet connectivity. We have a separate virtual machine that does, because some software nowadays refuses to install without internet connectivity. That's a bit of an annoyance, but our VM is just a standalone VM. Doesn't have internet connectivity, and we just inject the installation in it. Couple of weeks ago, Tom extended our environment with a manual VM just for that very purpose that I just explained. Okay, this is a piece of software. We need it on 2 devices. We're not gonna package it, but we quickly need the catalog. Okay, so at that point in time, we have a manual VM where we can basically run package inspector, start and stop ourselves, and get the catalog out. Roughly the same way as the automated fashion, but your installation portion is manual.
So the package inspector, we use that when we don't have a automated package that run from either Intune or Config Manager or another centralized system, right?
Well, the Config Manager extension that we showed in the last video actually uses package inspector in the backend as well. We just automate the package inspector start and stop portions there, but nothing is stopping you from doing that manually. Obviously, if you have a couple of hundred SCCM applications, it might be worthwhile to have an automated solution for that.
Cool.
So that's one way of doing it. The other way of doing it, which we use on occasion as well, is a package inspector scan. And the package inspector scan basically tells you, okay, I have this folder here. I need to make it trusted. Everything in this folder, I want to create a security catalog for everything in this folder. And all package inspector scan needs is the path to scan and then some parameters on what's the name of the catalog you want to use. And that's one of the things I've used for Martin's those notification scripts, because one of the things Martin does in the user profile update roaming those notification scripts is he generates some scripts, but these scripts are generated dynamically the first time he runs the new toast notification script. So these files aren't there. The files are somewhat embedded in the new toast notification script, and then these files are created on the fly. So what I did is, once I had one system with these files, I ran a package inspector scan of this particular folder, which created a security catalog for these number of files. And I then distributed these files as new dose notification.catalog. If we open that up, can actually look at the security catalog, and you can actually see the files that were being added. We've added some of our own files into that to make our dose notification solution work. But here you see the dose run package ID.ps1, dose run update ID.ps1, and things like that. They're just in that security catalog, which we've then again signed with our corporate signature so that these files appear to be trusted by our WDAC policy. So that's the portion on how difficult is it to operate this. And it largely goes to what with the applications that you don't want to package. The other thing is applications that you do want to package. Once you have WDAC in audit mode enabled, they make use of a functionality that's called the managed installer. And the managed installer allows you to define a number of processes so that when that process writes something to disk, the file is actually tagged as it was written to disk by this process. In the config manager world, that process typically is CCM exec. And if CCM exec does the download of the file, which it typically does, it'll tag that file as, okay, CCM exec has written that to disk. And then WDAC has an option of saying, okay, everything written to disk by CCM exec is trusted. So one of the pieces of software I use is a piece of software that does scanning of this tiny little silly scanner that I have here. But this tiny little scanner needs a piece of software before it can scan. So I need to install that software, and I needed it to run on a WDAC enforced device. So what did I do? I did create a package out of that in CN and deployed it with CN. Now, if you look at this package, Windows actually has a little command called fsutil, the file service util, which has some parameters telling it I want to look at a file and I want to query something. I want to query something that's called extended attributes. And in this particular instance, I'm going to look at one individual file, which is the executable for my Doxy scanner. And if we do that, and we scroll up a little bit, you see a whole bunch of extended attributes being created, but the one that we care about is this one. There's one particular extended attribute that is called $1 because it's in kernel mode, Smart Locker, because Smart Locker is the code name of managed installer internally at Microsoft, and then origin claim. And if you look at the origin claim, it's all ASCII-based text and so on, but most viewers will recognize this tiny little portion in the back saying, okay, so this was written to disk by something called C/Windows/CCM/CCM-exec.exit. And in doing so, it basically tells the system, okay, you can safely run this file because it was written to disk by my managed installer. That means me operating this is nothing out of the ordinary. It's you creating packages and applications in CM and installing them. And by doing so, the managed installer functionality will make sure they're trusted. The downside or the challenge here is not operating new packages. New packages typically aren't a problem. Your problem is the applications you've already deployed because you didn't enable WDAC audit mode way back when you started your original Windows 10 project.
And I was about to actually ask that question, because what about the applications that you deployed before having the WDAC policy enabled? And that's why you said, go ahead, enable that as the first thing.
Go ahead and enable that as soon as possible. And we've been shouting from the top of our social media lungs for quite a while, do this now. The sooner you do this, the sooner you benefit from this mechanism. And even if you have no intention of doing WDAC this year, enabling WDAC in audit mode this year, you'll congratulate yourself within 2 or 3 years if you want to look at WDAC and say, what an incredible, well-made decision did we make back in March 2022 to enable this. Because if not, the backlog of things you have to fix just becomes bigger. Whereas if you enable audit mode now and you define the right managed installers, your backlog becomes a whole lot smaller. So that's why the managed installer is amazing functionality, but the sooner you have it operational, the better. So our projects mainly exist out of 3 sections: enable WDAC in audit mode as soon as possible, create security catalogs in an automated fashion wherever feasible, and then the leftovers that we have to handle in a more manual fashion. That's typically the 3 huge streams, if you will, in a WDAC project. And then it kind of depends on the environment and how well managed / homogeneous or heterogeneous the environment is, to see how much work it's going to be to make a large chunk of your devices ready for WDAC and enforced mode.
So the managed installer, now we are talking about CCM exec, but if we are in a Intune world, we don't have necessarily the CCM exec installed on our devices. We have another executable running like EME, the Intune management extension.
Correct. Doesn't matter. You can actually define your own processes as a managed installer. So in the environments we do this in, we typically make both CM and Intune both managed installers. Obviously in cooperation with the customer, but even in environments that do not have Intune yet, we typically already make Intune a managed installer anyway. Because chances are people are going to do something with Intune at a later date anyway. And if they forget to enable Intune as a managed installer, they're building backlog again, which we want to avoid. So that's why we typically make both of them managed installers.
That's a good idea.
Yep.
And if we're using the store apps, they don't come typically from IME or CCM exec. They come from Windows Store directly. How would that fit into this environment?
Well, first of all, there's the question on WDAC as to whether you want to enforce it for store apps or not. We've definitely originally done some environments where we said, okay, things that are coming from the store typically have already been vetted somehow as to not being malicious. So one of the first questions to ask yourself is, do I want to enforce WDAC for store applications or not? There's definitely arguments for and against. So the argument against enforcing it is the applications are already vetted. Let's not make our world more difficult by doing this. The arguments for enforcing it is that Microsoft is now adding more and more applications into the store, for which you could definitely make the argument that you don't want them on your system. I think the entire sysinternal suite with PSExec, for instance, is now in the store. Could definitely make a case that given the potential for abuse of tools like PSExec to move laterally throughout the environment, that you don't want to have it on every individual system, or that you don't want a user to be able to install this themselves. Again, that's debates that a security team has to make. But if they don't want PSExec on there, then I'll have to handle store apps as well. There's no other way about it. If that happens to be the case, you'll probably have to build policy rules for individual store apps. Because I'm expecting, if you want to control the store, that the amount of applications that you want to install from the store is probably going to be a limited set of applications. And it's not going to be, or ideally at that point in time, it's not, I want the entire store, but not sysinterns. If that's something you want to do, that's going to be somewhat more challenging.
Yeah.
But if you say, no, there's just a dozen of applications I want to create from the store, creating a policy from a store application is actually documented fairly well. You just run one command to generate the XML for the application and you're done. So store applications are extremely difficult to make trusted.
And then the XML, you put that into the library that we saw in part 2, and you distribute that to the client, and then you're good to go.
Yeah, what we typically do though is we create one XML for all the store apps that you want to make trusted, and we distribute that as approved store applications.xml and done.
So the name of the XML.
Yeah.
Okay. And I mean, I have a very large customer where I operate right now, and they have 26 store apps. So it's not. I'm not blown away by doing this one by one because it's 26 apps. I mean,
yeah.
It's nothing.
No, it's not gonna break your operations by enforcing store applications. So we have a number of customers that actually do enforce it. We have a couple that do not. And I don't have a huge preference either way. As I said, I can make the argument for both cases, and I'm annoying that way every once in a while. If somebody makes the case for one, I'll make the case for the other, just because I can. I don't have a strong preference in this one. It's potato.
No.
There's some additional overhead. There's some additional security to be gained, but neither are extensive enough to really matter to me.
Yeah.
One of the interesting things you might have noticed in the backend is the Intune Windows agent.cat. I consider that an interesting one because it's not one that we create. It's something that Intune actually does in the backend. They generate a catalog for their own binaries and they actually distribute it to the folder that needs to have the catalogs to make sure that the Intune agent is trusted. So that was interesting for us to watch.
So that's nothing that you've put in there?
Nope.
Nope. Okay.
No, this is really really Intune doing this themselves.
Cool. The more automated, the better.
Yep. Yep. It's a clean way to make your own application trusted. So one of the ways I can demonstrate that this is not us is if you look at the digital signature, this is Microsoft. And I've asked for a private key for their certificate, but for one reason or another, they're not willing to hand that over. Guess they don't trust me really, which is probably a smart move.
Yeah. I can see that my my size of my file is 48 kilos and yours is 36.
Yep, and my date is older. Interesting on this particular device is that I'm still running a slightly older version of the Intune Windows agent because they forgot 2 files in the catalog I'm running. Which means if I try to upgrade it, the upgrade actually fails because it tries to run a file that is not trusted. So I still need to fix that on this test device.
So the MSI that comes directly from the blob storage that Microsoft provide to auto upgrade your Intune engine, the Intune management extension, is that failing on your device?
Yeah.
Wow.
And it's failing because WDAC is stopping it from running. Not the MSI itself. The MSI itself is trusted, but one of the files the MSI tries to run is not in their is not in their catalog, and in doing so, actually blocks the upgrade. So that's one of the things you'll learn in operations. You'll learn about vendors that forget to sign a binary. You'll learn it about things like this, like, okay, so the backend mechanism for the Intune Windows agent is apparently a catalog, and apparently they forgot to include a file that they probably should have included. Right? No biggie. My event viewer tells me which file is blocked. So all I have to do is create a catalog for that file once. Then the upgrade will succeed. And the new catalogs, we already verified that the new catalogs do contain those files. So successive upgrades will continue to work and will start working again. We haven't done that on this particular machine because it's one of the things that we tend to point out, like, look, these things will happen. It's an oversight by someone because not everybody is testing their upgrades in a WDAC enforced device. And so it's easy to miss that this catalog misses some files. So that's why we haven't done that here. The version of Intune Windows that I'm running does have the fix because we found a vulnerability in the managed installer functionality of the Intune agent that we've reported. This version already has the fix for that because otherwise we probably wouldn't allow it to run because then it could be used as a bypass for our WDAC policy.
Yeah.
But for now, we've allowed it to sit at this particular level. At some point, I'll probably have to upgrade it. as to not miss out on too many features that the Intune Windows agent provides, or to not leave vulnerabilities lingering that might have been found in more recent and have been fixed in more recent Intune versions. But that's why yours is, well, I was going to say that's why yours is bigger than mine. And at that point in time, I'm referencing the size of the Intune Windows agent gap before people make all sorts of crazy assumptions.
It's late evening, so one could, yeah, let's not go down that route. But that's great to know, and it's also great that you actually can pinpoint this to Microsoft when they forget to sign some of the files in the MSI package.
Yes. People that follow me on Twitter probably have noticed that I've done the same for Azure AD Connect. Azure AD Connect doesn't use the catalog mechanism. Azure AD Connect signs most of its binaries. Just as the Intune Windows agent, I believe they've forgotten 2 or 3 in some of the releases. So we typically point out, like, if you can sign 95% of your binaries, could you go all the way and sign 100%? Because if you sign 100%, I can actually build policies easier, especially for software that upgrades often. Policies can be more practical than catalogs. Because a catalog, whenever a file changes, a catalog no longer makes it trusted. In a policy, I can actually make it trusted, even if the version changes. And the only thing that has to remain the same is the name of the file and the publisher or the vendor of the software that actually signs it. So that allows me to create more flexible policies.
So if I was to make this trust of these 2 or 3 files, I would use the package inspector XE, and then I would create another catalog file.
Yep.
So I have 2 catalog files for the package, right?
Yep.
Okay.
Doesn't matter. As you can see, roughly by the size of the scroll bar, these are not all created by us. Right? There's, as you can see on the bottom left, there's 2028 catalogs already in that folder. And I would say, what did we create? I didn't create the Intune Windows agent. I believe these are the ones that we've put in there for this particular system. There's 2 new DOS notifications in there. I should probably clean out the older one, because as you can see, this is just for a newer version. I created 2 for some PowerShell modules that we run. There's one for the older version of Doxy that is now handled by Managed Installer, so that I could clean up. There's Process Explorer, because I used it to look at Managed Installer stuff. And there's the MSIX packaging tool to make sure that I can actually create MSIX on this system.
So just a hen and the egg problem here. Now, we need to distribute these files to this catalog, right? To this file path. And if I have enforce mode on WDAC and I want to distribute that as a MSI package, how can I actually do that without having the managed installer and config manager or Intune to do that? Could I do it manually?
You'll have to make sure your MSI is trusted. The easiest way would be just go sign your MSI and you're done. That would be one way of solving that. Our mechanism is a bit, well, I wouldn't say simpler. What we do is we actually create a package. It's in CM, but it doesn't really matter where the package comes from. And the package actually has 2 subfolders, active and archived. And then we have a PowerShell script at the beginning that says, okay, so everything that is inactive, copy that out to this particular folder. And then the script runs a second time through the archived folder and says, okay, everything that's in the archived folder, if you find it in this folder, go and delete it. Okay, so the archived is for us to have a mechanism like this one. I should probably take this one out because I don't want to keep old software trusted in the environment. Because if a new version exists, that might be because a vulnerability was found in an older version. So once I've done all of my upgrades, I actually want to make sure that nobody can copy an older version in and make use of a vulnerability in an older piece of software. So that's a bit of management that ideally you add to your operations.
Yeah, because now when you have third-party updates, your normal process would be, okay, we have this newer version of Google Chrome, and now I want to upgrade my environment, but you will at all times have different versions. You can't accomplish 100%.
No.
So it's also a, you need to juggle between and say, okay, when is it appropriate that I can take away the old client? It's not allowed anymore,
Yep.
right?
And that's a management / IT decision as to how many versions of Google Chrome can you be behind before I stop you from running it, and before I basically force you to open a help desk ticket so we can look at, so why haven't you received, or why did the installation of the update of Google Chrome fail on your device?
So I compare this a little bit against compliance policies in Intune and conditional access blocking your signal if your device is not compliant. Now, if your system is not upgraded to the newest version of Google Chrome, and that's the one you trusted, you are denied access to it. So
Yep.
you need to find out, why is my device not upgraded? Okay, because it has been deleted from Config Manager, or something broke, my config manager agent broke, so it cannot upgrade the package. So there we have it. The user would never have discovered this issue unless there was a system telling them, hey, your device is not okay.
Yep.
So could you compare it like that?
Yeah, you definitely can. And then the question we ask customers, and we pretty much leave them to answer what their preference is how many versions can I be done? And what I typically tell them is versions being down probably isn't the right way to look at it. I usually tell them specify a time frame. Because Google Chrome is terribly annoying in that it is very rapidly moving software. I think they generate 3 updates a month, if not more. So that can be pretty annoying. So if you're 3 versions down, sure, you're 1 month behind. Okay. There's obviously some vulnerabilities that will not have been patched and so on. Given that I run on a WDAC enforced device, making abuse of these vulnerabilities is going to be quite a bit harder on my device than on any other device on the planet. So there's something to be said to give people some leeway there. That being said, if you do the same for Adobe Acrobat, they probably create 1 update a year, maybe 2. So there, the amount of time that I'm behind is way bigger. And time means more people have figured out how the vulnerability can be used, how the executable can be abused for things, and so on. So we typically try to limit the amount of time that you have to start studying vulnerabilities more than the number of versions you can be behind, if that makes sense. So that's typically one of the other things that we look at.
Definitely do. Yeah, that's cool. I guess that I think that we went through the most of the stuff we've had for the agenda today. And I think with the knowledge we have now on the WDAC and how we should start and how where we should place the policies, how we should work with XMLs or catalog files or managed installers and use the package inspector for manual packages. And we have the end user possibilities with the toast notification, etc. We have the log analytics to centralize log events from our devices, etc. So I guess we have the whole package covered here for people to actually get started on WDAC. And that's what I wanted with these 3 videos. And I think you did a very, very good job on doing that, Kim.
Well, I think we both did a good job. The questions were to the point and made us indeed cover everything. I can go back, but I believe we allowed a whole bunch of people to get a serious kickstart in getting started with this. Because the amount of material that is out there, there's quite a bit of documentation, but the documentation that is available can be somewhat overwhelming as to, okay, so how do I do this? What is the preferred method? And this is just based on how we've been doing this for a number of months and based on a number of years of us reverse engineering how CM did it and trying to find our best methods in doing this.
Yeah. So yeah, I think we can stop sharing now, just so we get our faces on the screen. So that's good. Yeah. So reverse engineering, that's a cool term. When I go and dig into some Intune features, of course I go to the docs, but not all is documented, and especially on WDAC, I could imagine there's a lot of behind the scene. And this reverse engineering using some of the sysinternal tools, where do stuff, what is the process starts behind the scene, what does it do when I click this button, what happens on the device, where does it put files, etc. It takes a lot of time, Kim. And I could just imagine how much time you spent trying to do this and this and this and failed, and then at last you succeeded. And
well,
now
for CM, there's a couple of things we did. The interesting bit was our original reverse engineering on CM, to give some historic background, we actually enabled debug logging. And by enabling debug logging, we actually saw that CM ran 4 to 5 PowerShell scripts to handle its implementation. The interesting bit there was that the PowerShell scripts itself were actually encoded commands that were run, pretty extensive, long encoded commands. So our initial reverse engineering required me to look at PowerShell encoded commands and see how I could turn a PowerShell encoded command back into a PowerShell script. So that's one of the skills I learned along the way. Later on, to make our lives slightly easier, Tom actually had the great idea, instead of enabling debug logging and trying to decode an encoded command, why don't we just enable PowerShell transcript logging? that'll give you the scripts decoded and everything directly. And so that's what we've done at a later stage to get to the same scripts. And it's something that we use in reverse engineering Intune every once in a while as well. Just enable PowerShell transcript logging. If the mechanism that they use to implement actually relies on PowerShell, that will give you insight into the actual PowerShell scripts that they run, because PowerShell transcript logging logs the entire command stack of PowerShell.
That's a really cool tip right there.
And there's a, well, we've discussed WDAC with a number of people, and one of the folks said, I cannot do this if there's anything black box. I need to know exactly what is going to happen by enabling this policy. And so what I said is, here are the PowerShell scripts. And if you don't trust me, enable transcript logging on a test device and look at the scripts. Analyze the scripts. It doesn't become any more open than that. We like CM for its logging capabilities because it tells you everything it is doing. Well, if it's implemented through PowerShell and you can actually read the PowerShell script, that's a level beyond what a log will tell you. This is, you can actually look at the actual code that gets executed. And you can analyze all of it.
Wow.
So that's taught us a ton. The things we explained in the second video with merging XMLs that are called code integrity _.xml, that comes straight out of that. We had the PowerShell scripts and we noticed, hey, look, hey, here is our entry point in doing cool stuff.
So Mark Sylvie and the other engineers on the config manager team, they already did the job for us.
That they did the job for us in allowing to be WDAC, make it extensible for our needs.
That's cool.
Yep.
That's a very good trick and very good to know. And for everyone who sits and want to dig into this, they should definitely go and do the same tricks here. That's the way forward. So Kim, before we say goodbye, I had a question on the part 2 here. A YouTuber called A Prime Problem, and he has 3 questions, and the one goes, how did you generate the native images XML file?
The native images XML file, we actually make use of one of the features that was added to Windows 10. I'm going to gamble, I believe 18 or 9, which allows you to create path rules. And path rules just allow you to say, okay, anything within this folder is allowed to run. I typically hate path rules because they're often an easy bypass for application approved listing technology. So I typically don't like them, but the way WDAC has implemented them is kind of nice. Even if something is copied into the folder, if the folder is writable by anybody that is not an admin, then even if you have created the path rule, WDAC will still block it.
Okay.
Which can be interesting if you try to make the root temp folder trusted and you create a path rule and it doesn't work as expected. Well, that's why. Even if you created the path rule, if the folder is user writable, the executables will still be blocked. So that makes path rules somewhat more acceptable in a WDAC scenario than in most other environments. Maybe I'll need to share my screen again to show these native images, because apparently the user asking the question probably already played a little bit with it and knows what they are.
Mm-hmm.
Right? But it's one of the things that you'll see relatively often, and immediately if you enable your auditing, you'll end up with files like this. In this particular instance, admin UI.new secondary site.ni for native images.dll. These are annoying files because of this. As you can see, they're not code signed.
No.
And that's because all of them are generated locally on your system. It's a .NET functionality to optimize code execution specifically for your system. So the other challenge is, since this is specifically for my system, I cannot rely on centralized hash rules either, because the file is going to be different on a whole bunch of machines in my environment. Right? So there's no good way of making these files trusted. If you look at the WDAC documentation, the WDAC documentation will say, well, just ignore these files being blocked. Because if this file is being blocked, the performance optimized version of this DLL, it'll just fall back to the admin UI new secondary site without the ni.dll, and code should still function fine. So if you look at the WDAC documentation, it just says, just ignore these files being blocked. We decided not to do that for two reasons. One, there could be a performance penalty, although everybody we talk to is saying it's gonna be neglectable. You're not gonna notice any performance impact. The reason we decided to make all of these files trusted, though, was because they were annoying in our event viewer and our event logging, because these files create a bunch of events after every reboot. So that's why we decided to make them trusted with that native images.
Makes sense.
But it's just a path rule to these two folders. And if you have .NET 2.0, you'll actually find two other folders for .NET 2.0. So we typically include all four of them, just to be sure that if you, for one reason or another, still have to install .NET 2.0 after the fact, we have that covered too.
Great. That's a good explanation. So next question. Is it possible to generate the security catalog files and deploy them in an environment without SCCM?
I think that's probably become clear through our explanation of the package inspector in this call, but yes, the minute you have your security catalog and you have your security catalog code site with a certificate that is in your WDAC policy, it doesn't matter where the catalog came from. As we explained in the second video, security catalogs is the exact same mechanism that drivers have been using for 2 decades. You have no clue how they generated that catalog either, whether it's through CM or anything else. If the catalog is in the right spot, it'll just work.
And the last question. Can you do a compare of Windows Server 2016 WDAC functionality that the majority of, maybe people are using now, and to the Server 2019 or maybe 2022?
I'll share my screen again. This is the service release support matrix. So we have the comparison of all the server operating systems. If you look at WDAC for Windows Server 2012, it's pretty easy. There's no support for WDAC in Server 2012. WDAC is supported from Server 2016 to Server 2022. second thing to look at is Server 2016 itself is not supported to receive the WDAC policies from within SCCM. Right. So if you want to do WDAC on these devices, from a support point of view, you actually have to create and deploy the policies yourself. Right. So that's one of the other differences. Then there's the no, yes, no, yes, no, yes. Managed installer functionality is not supported on any of the Windows Server core editions. Right? Even at Server 2022, the core editions cannot rely on the managed installer technology. People often consider that to be a pity. That being said, I don't know a huge amount of organizations that actually install the software on their servers using SCCM applications or packages. So it's often much less of a deal as what people think it might be. Losing managed installer on workstations would be much more problematic.
Yeah, but they don't run core, right? They have a UI and.
Yes, that's the other thing. Core isn't necessarily the most popular way of running servers nowadays. And then the other interesting bit is that you need Server 2022 before you can actually rely on file path rules on a server operating system. So that's a bit of the sliding scale as to what is supported. So that means that the thing we saw around the native images are still a bit of a pain in Windows Server 2016 and Windows Server 2019.
And that's a good reason to be on the most recent server operating system.
Yep.
Yeah.
And the things we're trying to do this for as first in our servers are actually what we call the crucial servers. So the very first thing we're looking at is domain controllers, PKI servers, and your config manager infrastructure if you can. And at least the first two don't run much else than Microsoft software. So migrating those or upgrading those to Windows Server 2022 shouldn't be that big of a deal.
No. Makes sense. WDAC on a config manager server, though.
It's one of the things we'll probably discuss a little bit in our MMS session. There's some special things there, but from a security point of view, being able to protect your systems management solution absolutely makes a ton of sense. But it's obviously not as easy a policy to build as the policy for your domain controller or PKI server.
Yeah.
That's
I guess so.
Without any doubt.
Without any doubt. So Kim, that was 3 sessions, and wow, I'm blown away by your knowledge on this area. I believe you have knowledge on many areas, but on WDAC, wow, you really know your stuff. And for people or maybe customer looking at this video, reach out to Kim if you have any questions or want to hire him or his colleagues for making such a beautiful environment where we have whitelisting software and make our system more trustworthy. So Kim, it's been a absolutely pleasure to have you on the show, and thank you so much for spending your evenings here with me. Thank you so much.
It was great chatting because that's all it felt like. Chatting to somebody about technology we both like.
Likewise, likewise. So this 1.5 hour just went away.
Yep.
That's how it is. But thank you again, and thank you viewers for looking at 3 videos in 1.5 hour. Yeah, it's great to have you on board, and really hope that you learned as much as I did. And yeah, thank you, and have a very good night.
Bye, folks.